Lesson 9.4, Graphing Sine and Cosine Functions. Our essential question: how do you explore characteristics, stretch and shrink, translate and reflect graphs of sine and cosine functions? There were 3 problems left on the page for independent practice. Let's go ahead and take a look at those. So here's my next problem. I know that my A is 5 and my B is 1. To be able to graph sine, first I need to figure out what my amplitude is, and that's the formula, the absolute value of A. A is 5, so it's the absolute value of 5, which I know to be 5. That means from the midline, it needs to be 5 high, which means I'm going to have to rescale my y-axis because I need to make sure it gets as high as 5. Well, how long is each segment? That's what our period is, and that's 2 pi over the absolute value of b. My b is 1, so this is 2 pi over the absolute value of 1. The absolute value of 1 is 1. So this is 2 pi over 1, which is 2 pi. So my segments are going to repeat every 2 pi, which meant I have enough space here to be my repeat. So now I just need to find my 5 key points. And sine has 3 x-intercepts. The first x-intercept is always at 0, 0. Our second and third x-intercepts are formulas. Both formulas need b, which is 1. So let's go ahead and use our formulas. So I just found our 3 x-intercepts. The last 2 key points that we need are your max and your min, which are both formulas. They require b as 1, and they both have a as 5. So using our formulas, here's our max, and here's our min. So we already determined that our period, which is 2 pi, is how long our graph needs to at least be. So our graph for the x is fine. Our y, our highest y value is 5. So we need to make sure that this counts to 5. So I'm going to rescale so that it will now fit. So graphing my x-intercepts first, I see that my x-intercepts land on the whole pi values. So continuing on the whole pi values, I have all my x-intercepts now. My max is at pi halves 5, and my min is at 3 pi halves negative 5. My period lasts from 0 to 2 pi. This is the repeated segment that will last as I continue to go up and down my x-axis. So 0, 5, 0, negative 5, 0, 5, I'm out of space, 5, 0, negative 5, 0, 5, and I'm out of space. So here is my graph, and this is my sine. We are now being asked to describe the transformation. The A always tells us our vertical stretch or shrink. Because it's bigger than 1, we are stretching. So this is a vertical stretch by a factor of 5. And B is our horizontal stretch or shrink. B is 1. 1 meant nothing was happening. So there is no horizontal stretch or shrink. Our next sine graph, I see that my A is 1 and that my B is 2. To be able to graph it, first we have to find our amplitude, which is the formula absolute value of A, which meant we're doing the absolute value of 1, which is 1. So that meant that from the midline, I'm going to get as high as 1. So my amplitude says my mountainside will be as high as 1. Period. How long is the segment before it starts to repeat? That is 2 pi all over the absolute value of B. B is 2. So this is 2 pi all over the absolute value of 2, which is 2 pi over 2, which is pi. So my period, my segment, will last until pi, and then it will start repeating again. Now I need my 5 key points. For the sine, you have 3 x-intercepts. X-intercept number 1 is the coordinate point 0, 0. Your other 2 x-intercepts are formulas. Both x-intercepts require the use of b. B is 2, so using your formula, So I just found all 3 of my x-intercepts, 3 of the 5 points. My 4th point is my max, which is a formula, and my 5th point is my min, which is also a formula. They both require my b, which is 2, and they both require my a, which is 1. My max and my min. So my period repeats after pi. I have plenty of space on my x. My amplitude is high as 1. My highest x value is pi, so I'm good. My highest y value is 1 and -1, so I'm okay. So I don't need to rescale anything. So my x-intercepts are at 0, 0, pi halves 0, and pi 0. I see that I am on as an x-intercept every single half. So I'm going to continue, and every half pi is going to continue to get an x-intercept. My max is at pi fourths 1, and my min is at 3 pi fourths -1. So from 0 to pi, that is my repeated segment. And this is going to repeat as we go up and down the chain. So 0, 1, 0, -1, 0, 1, 0, -1, 0, 1, 0, ran out of space. Go in the other direction. 1, 0, -1, 0, 1, 0, -1, 0, 1. And we're going to connect these. Now this sine graph looks really tight. It's all like squished together. And that's because of this horizontal here. Let's go ahead and look at our transformations. Our A is 1. This is supposed to be our vertical stretch or shrink. If it's a 1, that meant there was none. So we have no vertical stretch or shrink. B is horizontal. B is 2. So this means we have a horizontal, and it's going to be a shrink. Why is it a shrink? It's a shrink because it's a factor of 1/2. Because remember, you're supposed to reciprocal it, and 1/2 is smaller than 1. That's why it looks so much, it's like squished. It's because we took the horizontal and we shrunk it by 1/2. Our last one. A is 4, B is 2 pi. So to be able to graph this, we need to find our amplitude, which is the formula, the absolute value of A, which meant we have the absolute value of 4, which is 4, which meant I need to be able to get up to 4 high, which means this y-axis is going to need to be changed. My period tells me how long it's going to be before it starts repeating. 2 pi all over the absolute value of B is that formula. So 2 pi all over the absolute value of B is 2 pi. So I end up having 2 pi all over 2 pi, which gives me 1, which meant my period needs to at least count to 1, which means my x-axis also is going to need to be rescaled. So before we scale them, let's go ahead and find our 5 key points to see if we can make sure we scale right. Remember, you have 3 x-intercepts on sine. 0, 0 is x-intercept number 1. X-intercepts number 2 and 3 are formulas. They both require b, which is 2 pi. So go ahead and putting that into our formula. So I went ahead and I found my 3 x-intercepts. We have 2 more points we need to find, our max and our min, and both of those are formulas. They require b of 2 pi and a's, which are 4. Here's my max. And there's my min. All right, my x's need to be able to get as high as 1. So let's go ahead and scale these by 1/2. And my y's need to get as high as 4. So we're going to go ahead and scale these by 4. So my x-intercept is 0, 0, 1/2 0, and 1, 0. So it looks like on every x scale we have an x-intercept. So we're going to go ahead and continue through those x-intercepts. I have a max at 1/4 4, and a min at 3/4 -4. So I go 0, 4, 0, -4. 0, 4, 0, -4. 0, 4, 0. Well, you're done going that way. Backwards. I see 4, 0, -4. 0, 4, 0, -4, 0, 4, and I ran out of space. So this is my sine graph. Last, we need to describe our transformations. Your A, which is 4, all those tells us are vertical. So this is a vertical because it's bigger than 1. This is going to be a vertical stretch. So it's a vertical stretch by a factor of 4. Your B, which is 2 pi, always tells us are horizontal. This is going to be a horizontal shrink. And why is it a horizontal shrink? It's because it's by a factor of, the reciprocal of this is 1 over 2 pi, which is smaller than 1. So it's going to be a shrink.